I just finished building an extendable hash table for an open source relational database management system called BusTub. Check out my previous video if you don't know what BusTub is, but it's basically an educational database management system built by the database group at Carnegie Mellon University. It comes with an interactive shell just like the Postgres shell, but it isn't fully functional yet, and the idea is that students build out the critical components of the system to get it up and running. The assignments in the graduate level course CMU 15445 challenge students to implement the system in stages, and in this video I'll go over how I completed this second assignment, which is a disk-based extendable hash table. This hash table makes heavy use of the buffer pool manager from assignment 1, which I've already implemented, so if you haven't seen this video, which is on the screen right now, go check that out. Last night I finally got all of the tests passing. It was definitely challenging, and I did spend quite a few hours debugging my code, but overall I think this assignment was easier than the first assignment, mainly because the first assignment got me up to speed with most of the C++ language concepts used in the development of BusTub. So in our quest to get BusTub fully operational, we now need to build this extendable hash table so that we can perform lookup, insert, and delete operations on the data inside our database in a way that is efficient, regardless of where the data is located, be that in main memory or on disk. The reason we use a hash table in general is because it lets us perform the required operations, essentially with constant time complexity. An extendable hash table gives us the benefits of a hash table along with roughly linear space complexity, because the extendable hash table can grow and shrink to cater to the number of elements inside of it. Another benefit of extendable hash tables is the fact that we can store key value pairs in buckets, which we can store in individual memory pages. This means that we don't have to store the entire hash table in memory, we can store parts of it on disk as needed. Here's how it works in BusTub. Anytime BusTub needs to perform some SQL operation on the data in a database, like a join operation or calling an aggregate function or something like that, it makes use of the hash table for both reading and writing. The hash table maintains a directory, which is a hash index that stores pointers to buckets. Each bucket is where our key value pairs are stored. The cool part is, each of the buckets and the directory can fit into memory pages. Anytime we need to look inside a bucket, we can just fetch it from the buffer pool manager, which I implemented in the previous assignment. This is convenient because the buffer pool manager abstracts away any notion of memory exhaustion from the hash table. We can keep fetching and creating pages as needed, because if we run out of memory, the buffer pool manager will evict pages to the disk to make more room. Our only real limit is the max size of the directory, but in the actual implementation, we can add more directories to keep growing the hash table if needed. I ran into two main challenges in this assignment. The first one was learning C++ move semantics. If you don't know anything about move semantics, you're going to have a bad time with task number 1. It's basically a crash course on move semantics. You will have to implement move constructors and overload the move assignment operator. I own a physical copy of this book, which I have read previously, so I knew the concepts behind move semantics, but actually implementing them was a fun challenge and a great way to solidify that knowledge. This was also a really good reference book to use. The second challenge I ran into was spending a lot of time debugging the logic for the remove method. I had issues with the requirement of recursively merging empty buckets, and the reason I was having problems was pretty simple. I didn't take the time to learn how the merge operation was supposed to be done. I really would have benefited from slowing down, doing some examples on paper, and really learning the ins and outs of the operation itself. Instead, I decided to not do that and just waste hours going on wild goose chases through the code. The problem ended up being something really silly. After merging two buckets, I wasn't updating the pointers in the directory to point to the merged bucket. Had I just done a few examples on paper, I would have known that was a step that I had to implement. So this challenge was purely self-inflicted, and had I not been so stubborn in my approach, I could have saved precious hours. Now, I don't want to repeat this mistake again, so for the next assignment, I'll be setting myself a learning objective, and that is take the time to learn the theory behind the implementation, write out examples on a piece of paper, and do more examples than I think I need to. Ideally, this will give me a holistic view of the entire implementation and will hopefully reduce the chances of me missing something. Another fun little challenge I faced was some bit manipulation challenges. They weren't really difficult or anything, but they were fun, and bit manipulation is something that I never get to do in my day job as a full stack developer, so it's always fun to play around with. This one in particular, the challenge was, how do you add a 1 in front of the most significant bit of a binary representation of an unsigned integer? So for example, if you have 100, how do you get 1100? And then the opposite of that is, how do you remove the most significant bit? For example, if you have 1100, how do you get 100. This was my implementation of it, but apparently you can also do it with the exclusive OR operator too, which might even be more efficient than my solution. So yeah, I'm having lots of fun with these assignments, and I'm learning way more than I ever could from just reading books on C++. If you want to improve your C++ and your coding skills in general, definitely give this course a try. I don't think there's anything else like it anywhere on the web. I highly recommend it. And when you finally get 100% of the tests passing after hours of work, believe me, it's the best feeling ever. Anyway, thanks for watching. I'll see you guys in the next video for assignment 3.